All right, welcome back, everybody. We're gonna start 7.4. Seven point four is on the double angle and half angle identities. And let's find some of the basic ones, straight up gate. Uh, which one do you guys want to do first, cosine or sine? Sine, all right, let's do sine first. So sine of 2a is the same thing as sine of a plus a. And so remember, it's normally like if we had a plus b on sine, it would be sine a cosine b plus cosine a sine b. Well, now the b's are getting replaced with a's, and we have sine a cosine a plus cosine a sine a. But those are the same thing. So sine of 2a or sine of 2 theta. I'll use a because I did it earlier. Sine of 2a is 2 sine a cosine a. Then we'll look at cosine. So we'll do cosine. Let's write what a plus b would normally be. That's gonna be cosine a cosine b minus sine a sine b. When we do cosine of 2a, this is cosine of a plus a. And all of our b's get switched to a's. We have cosine a minus sine a sine a. And that cleans up to cosine squared a minus sine squared a. This one has two variants to it, two other variants to it. We have a formula that has cosine squared or sine squared in it, right? So if we use cosine squared a plus sine squared a equals 1. We can come up with two variants of this. And one of them, we will replace cosine squared a with 1 minus sine squared a. And the other, we will replace sine squared a with 1 minus cosine squared a. But you process that for a second, and we'll write it down. Alright, so let's just look to see what happens when we do this one. We have cosine 2a. And we're gonna replace cosine squared with 1 minus sine squared. And then I have the original minus sine squared a. So one of these variants is cosine 2a equals 1 minus 2 sine squared a. And on the other one, cosine 2a equals cosine squared a minus, and then we're replacing sine squared, so I'm gonna put this in parentheses. Cause that minus needs to distribute to both of them. That's the part I replaced. When we distribute the minus, this will be a minus 1 plus cosine squared. So cosine 2a can also be written as 2 cosine squared a minus 1. And we'll make a little table that puts all these together in a second. Is everyone okay with this? So that was the derivation of the sine and cosine. If we wanted to do tangent of 2a, that's tangent of a plus a. Which is gonna be tan a plus tan a over 1 minus tan a times tan a. So tangent of 2a is 2 tangent a over 1 minus tangent squared a. So if I put a little chart together of all of them, we've got tan 2a there. Sine of 2a was 2 sine a cosine a. And then we'll do the 3 variants of cosine 2a. All next to each other. Sine squared a minus sine squared a. 2 cosine squared a minus 1. And 1 minus 2 sine squared a. These are our double angle identities. Alright, so why do we care? First off, this gives us a means to, especially with cosines one. Switch between cosine and sine if there's squares involved and stuff like that. That's gonna help immensely in calculus. When sometimes integrals, like in calculus 2, we were just got done doing it. You're working with cosine squared and sine squared, and like it's hard to do by itself. But if we can write everything as sine squareds, it gets a lot easier. It allows us to shift back and forth between things. It also is gonna give us means to switch to the half angles in a second, you can see that. Just by making a little substitution here. Which is gonna like we know 45 degrees, but what about 22.5 degrees? There's simple formulas that can do that without having to grab a calculator, well. I don't know about not grabbing a calculator, but. Everyone got the formulas? Alright, let's do some examples using them. Given sine theta equals 8/17. And cosine theta is less than 0. Find sine of 2 theta, cosine of 2 theta. And tangent of 2 theta. Just get some practice in using these formulas. Alright, so what quadrant is theta in? Why do you say that?
Sine is positive with the positive line. And if cosine doesn't do it, it's negative.
Sine is positive, cosine is negative, that is indeed quadrant 2. So that's gonna help us identify whether we need a negative sign or positive sign when we're doing this stuff. So cosine of 2 theta. Let's start with sine. Well, we kind of need to do sine of 2 theta and we need cosine of theta, right? So maybe let's start there. Let's go with finding cosine theta. Let's see, how do we want to go about this? We can either make the triangle or you know what, let's get some practice in using the cosine squared theta plus sine squared theta instead of making the triangle. This will be cosine squared theta plus 8/17 squared equals 1. So cosine squared theta equals 1 minus 64/17 squared is 289. We'll get a common denominator. And that is 225/289. When we take the square root, we get cosine theta equals plus or minus the square root of that. Square root of 225 is 15. And we already know the square root of 289 is 17. And since cosine theta is less than 0, we're in quadrant 2. Cosine theta is negative 15/17. Alright, so now we can start exploring sine 2 theta, cosine 2 theta, and tangent 2 theta. Sine of 2 theta is 2 sine theta cosine theta. Which is gonna be 2 times 8/17 times negative 15/17. And this is negative 240/289. Cosine of 2 theta. We can use any of them, but I don't know, I'm gonna do cosine squared minus sine squared. Cause the reason why I wanna do that is I have cosine squared right there. And I have sine squared right there, so I already have the math calculated for both of those. Cosine squared was 225/289. And sine squared was 64/289. And let's see, if I subtract that. If I subtracted 50, I'd be at 175, then another 14 gets me down to 161. Then we look at tangent 2 theta. That does not have options, it's 2 tangent theta over 1 minus tangent squared theta. I guess we need tangent, don't we? We don't have that listed. So tangent will be sine over cosine. (8/17) over negative 15/17. Should clean up to negative 8/15. I got that just by multiplying. Multiply by 17/17. That gets rid of the complex fraction part. And we'll put that in up here. 2 times negative 8/15 over 1 minus negative 8/15 squared. Let's see, I've got negative 16/15 on the top. And 1 minus 64 over 225 on bottom. I'm gonna leave the 225 as 15 squared, because it's gonna be a little bit easier to see what my next step is, that's 15 squared. I'll multiply by 15 squared on top and bottom. So this will be negative 16. One of the 15s will cancel out on top, we get 16 times 15. Over 15 squared minus 64 on bottom. And I don't know what the hell that is, where's my calculator? Moving negative 240 on top. This will be tangent to theta. Over 161. That seems like a lot of work to get tangent to theta, is there an easier way? Like I had to find tangent theta and then we had this giant clusterfuck of a complex fraction. Is there an easier way? And there is. Anyone think what it might be? I wouldn't go with square, yeah, one over the other. We could have just done tangent to theta equals sine of 2 theta over cosine 2 theta. We already calculated those. Negative 240 over 289. Divided by cosine was 161 over 289. Multiply this by 289 over 289 to get rid of the complex fractions. And we got negative 240 over 161 a lot quicker. That was quicker because we'd already done sine and cosine. Now, if you hadn't done sine and cosine, that's more work. If you only needed tangent to theta, it's more work. One more question before we go on to another example. So if theta is in quadrant 2, theta could be 91 degrees up to 179 degrees. So if I doubled it, that's like 182 degrees up to 358 degrees. That's in quadrant 3 and that's in quadrant 4. So like there's 2 possible areas it's a line. Where is 2 theta? Well, let's look, sine was negative. We knew that was gonna be negative. Sine of 2 theta was negative. Because quadrant 3 and quadrant 4 are both negative for that. Cosine was positive. What quadrant has sine negative but cosine positive? 4. So this will be quadrant 4. Alright, ready for another example? Not the most exciting thing. The formulas are the most useful part of this. Doing this is kind of like almost busy work. Feels like, doesn't it? Doing some problems like this, but like the formulas are really helpful. I know y'all didn't like the verifying trig identities things, but it's like one of the most useful skills in this chapter. In calculus. And these identities add to your ability to do stuff like that. So let's say cosine two theta. Equals -12/13. And we have theta is between 180 degrees and 270 degrees. Let's find sine theta, cosine theta, and tangent theta. Yeah, let's just do sine theta and cosine theta. You can do tangent theta just by division. Yeah, fuck it, we'll throw in tangent theta. Alright, well. We gotta get two theta down to theta. Right? So we've got some formulas for cosine two theta that we can use. We got cosine squared theta minus sine squared theta. We've got two cosine squared theta minus one. And we've got one minus two sine squared theta. I don't know that the first one's helpful. This one is not gonna help us. Not helpful right now. So we'll cross that one out. The other two might work though. So cosine of two theta, which we know is -12/13. We'll say that equals two cosine squared theta minus one. If I add one to both sides, I'm gonna write this as 13/13 over here, that's one. I can get 1/13 equals two cosine squared theta. Divide by two and I get cosine squared theta equals 1/26. Which means cosine theta has to equal plus or minus the square root of 26. Oh, I jumped ahead. Square root of 1/26. Which sign is it? Can't be both, it's gotta be one of them. Why?
The negative.
It is negative, we're in quadrant 3. And if we. Rationalize the denominator, we get that. Cause that's the square root of 1/26, so 1/square root of 26. Multiply by root 26 over root 26. Bam. Now we have some options, we could do the formula for the 1 minus 2 sine squared theta. But maybe for practice, we'll go back to doing triangles, we know we're in quadrant 3. So we can make a right triangle here. And our reference angle is that. And cosine is adjacent over hypotenuse. Which means hypotenuse is 26. And this is negative square root of 26. Keep practicing all those different kinds of skills here. You all right, Davis? That makes sense. I can start bringing a square bottle, have Jordan, hand it to Jordan so she can squirt you when you get sleeping.
So I didn't sound almost strong that pepper spray.
You gotta start bringing coffee, or like a Red Bull or some shit like that. Meth, no, don't do meth. Meth is bad. I know, I did it for a long time, don't do meth. I was young and stupid at some point. Alright, a squared plus b squared equals c squared. A squared plus negative or 26. Plus, there we go, that squared equals 26 squared. So a squared plus 26 equals, what the hell is 26 squared? It's above 625, I know that. 676. So a squared is gonna equal 650. 650. And I'm gonna write that as 25 times 26, because I know that's gonna simplify some. I knew it was. All that big number has gotta simplify, when I take the square root of 25 is 5, and then we got 26. And we are in quadrant 3, which makes a negative. So, we've got cosine. Cosine theta was negative root 26 over 26. Sine of theta, I can get from the picture now. Negative 5 root 26 over 26. And tangent is opposite over adjacent. It looks like 5. Alright, wait for that. I got you, this problem not that big. Let's simplify. We're gonna have 2 cosines squared 5x minus 1. So if I say theta equals 5x. This looks like 2 cosine squared theta minus 1. And what does that equal?
Cosine.
That's cosine of 2 theta. But theta was 5x, so this is cosine of 2 times 5x, or cosine of 10x. Okay. What about sine of 165 degrees, cosine of 165 degrees? Well, here, if I go with theta equals 165 degrees. This looks like sine theta, cosine theta. And that's pretty close to sine of 2 theta. Sine of 2 theta was 2 sine theta cosine theta. So if I wanted just sine theta cosine theta, I could divide both sides by 2 or multiply by 1/2. And I'm gonna get this equals 1/2 sine of 2 theta. Or sine of 2 theta divided by 2. And that's gonna equal 1/2 of sine of 2 times 165 degrees. Which is sine of 330. Do we know what sine of 330 is? It's negative 1/2. So this is negative 1/4. Let's take a 10-minute break. There is another way to do this, and I'm gonna show it to you after the break. And you're gonna be like, "Fuck." Alright, so. We had a sine theta cosine theta a second ago. And we used 2 sine theta cosine theta, we switched to. We used a sine 2 theta version. There are formulas called product to sum. And sum to product. The product to sum formulas are. And you'll note I'm going to reference my cheat sheet because I do not have that memorized. Let's start off with the one I gave, sine theta, cosine theta. We can write this as 1/2 of sine of A plus B plus sine of A minus B. Does that make sense? Let's see. We've got 1/2 of sine A cosine B plus cosine A sine B. And then plus sine A cosine B. I should say sine A and B right here. not theta and theta, they're different angles. Sine A cosine B. Minus. Cosine A sine B. And you'll see we have the positive version of that and the negative version of that, those will cancel. And we will get 1/2 of sine A cosine B. Plus sine A cosine B. Is 1/2 times 2 of them. And we do get sine A cosine B. That's what I wanted to do the derivation of one of the formulas for you, that's where they come from. Let's just list the formulas in general, and we got a chance to write those down. If we want a general list of them. Cosine A cosine B. Is 1/2. Cosine of A plus B. Plus cosine A minus B. Sine A sine B. Is almost identical. We've got 1/2 cosine A plus B, but then this switches to a minus here. Cosine A minus B. So the two product of sum come from the cosine formulas. Where the trig functions match. When the trig functions don't match, like we had above, sine A cosine B. Is 1/2 sine A plus B. Plus sine A minus B. And this seems silly, and I'm not really, I'd have to like work them out to see why they're different. Oh, I know why. I know exactly why. This is. Almost identical, other than. The sign changes here to a minus. These are your product to sum formulas. Are there any tests? It is important that you know they exist. Because if you want to use them, they're available to you. Like you can always go look them up when you know. Knowing's half the fucking battle. If you know something's there, you can always go fucking Google it or ask AI what the formula is. You ask AI a formula, it should give you the right formula. If you ask it to do math. You're fucking throwing dice right now. I promise you, you're throwing dice. I had to try to, check my solution set or solutions to a test. For Calc 2, and it got not a single fucking question correct. It would fuck up algebra. It would fuck up arithmetic. 2 plus 3 was fucking 6. I'm like, Jesus Christ, what the? But if you don't know it's wrong. And you don't look at it and go, does that make sense? And you just use AI, you're gonna get the wrong fucking answer. Don't use AI for math, folks. There is another set that I'm gonna show you. It's the reverse of this, sum to product. Also not being tested on, but it's important to know they exist. So sine of A plus sine of B. This is gonna equal 2 sine of A plus B over 2. Cosine of A minus B over 2. Yeah, whoever came up with these was having a fun day. Then if we switch to minus sine B. It alternates the signs inside. This becomes A minus B over 2, and cosine becomes plus. And that's based on doing like the odd identity. Like that could be rewritten as sine of A plus sine of negative B. And that's why they look the same or similar. Then there's our cosine ones. Cosine of A plus cosine of B. And these double up on the same trig functions. We will have A plus B over 2 and cosine of A minus B over 2. And then cosine of A minus cosine of B equals 2 sine, these are both sines here. Sine of A plus B times sine of A minus. Both angles over 2. But
I'm surprised when the song.
so sum to a product. Like subtraction can only be written as addition of the opposite, so these are all sum formulas.
Why is cosine keep on going?
Why is cosine going to sine?
Because it's subtraction. It's just
Would you, we could spend a lot of time trying to derive these formulas for something you're not gonna need.
It's just right.
Let's just go with it's right. If you really want to, you're like, after everyone else has left, I will walk through it with you.
Not it.
Again, these aren't gonna be on your test, but it is important to know they exist. Cause they will help, it can be helpful, but in general, no. And it's all just manipulating functions we've had before, it's just finding the right manipulation. Stuff that will help you though is like doing, now that we've got. Like cosine x and cosine 2x and shit like that, we can get other angle formulas going on. And so when you're done writing this down, we'll look at like, let's find a formula for cosine 3x. We now have the tools to do that. Not with these product and sums, but like the ones we did before. Alright. So. Cosine 3x. We wanna write this as single angles. So we'll start off with like cosine x plus 2x. So this is a plus b. The cosine formula is cosine cosine. So cosine x, cosine 2x. And then we change signs and do sine a sine b. So sine x, sine 2x. Alright, well, we can break cosine 2x down into. We can treat that as 2 cosine squared x. Minus 1. And then we've got minus sine x. And sine of 2x is 2 sine x cosine x.
This,
If we clean this up, we've got 2 cosine cubed x. Minus cosine x. Minus 2 sine squared x. Cosine x. It's down to single angles, which is good. It's kind of messy. Let's switch to just cosines. Let's go to just cosines. So we've got 2 cosine cubed x minus cosine x. And sine squared x is the same as 1 minus cosine squared x. And then times cosine x. Maybe I'll do that in a bracket to show that's the one I changed. That part's not changing yet. I've got minus 2 times 1 times cosine x is minus 2 cosine x. And then I got minus 2 times negative cosine squared x is 2 cosine squared x. Times cosine x is plus 2 cosine cubed x. And gathering like terms, 4 cosine cubed x minus 3 cosine x. That's pretty simplified. We actually have the means to write in terms of just sines too. How about just sines? To do that here, I'm gonna factor out a cosine x. And make this 4 cosine squared x minus 3, not equals, times. This one gets kind of ugly. The 4 part is fine, cosine squared is 1 minus sine squared. That gets that part gone. The question is switching cosine x to sine x. Oh shit, now I want that fucking angle thing we did with 90 degrees, that's probably the easiest way to do this. What were those stupid formulas? It was 90 minus theta. I think that's right. 90 minus theta. Maybe this one is. Yeah, cosine theta is sine of 90 minus theta. So I can do this as sine of 90 degrees minus x. Wait, that's gonna switch to cosines and sines though, that's not helpful. We don't want that, I guess it would work, but we could also do. Since cosine squared x equals 1 minus sine squared x. We could say this is the square root. We could go with square root of 1 minus sine squared x. Times 4 minus 4 sine squared x. Minus 3. There's a lot, we're down to sines, ugly. There might be some more manipulations, but we did get it in just in terms of sines. And we've got one more topic to go with you. And let's go. I'm gonna start the derivation of it before David leaves, that way he sees how it starts and he can find the rest easily on his own. These are the half angle formulas. Cosine of theta over 2, what does that equal? So the way you start is start with your cosine of 2 theta formulas. If I write this as 2 cosine squared theta minus 1. I can solve for cosine theta here. I add 1 to both sides. I'll divide by 2. And I get cosine squared theta equals 1 plus cosine 2 theta over 2. We will take the square root. So cosine theta equals plus or minus square root of 1 plus cosine 2 theta over 2. And we do a boring substitution. Say x equals 2 theta. So theta equals 1/2 x. So cosine of 1/2 x equals plus or minus 1 plus cosine x over 2. And that's the half angle formula for cosine. So you can derive it from the other ones, it's not that exciting. The sine one. Sine of 1/2 x. Actually does the same thing with doing the 1 minus 2 sine squared. And if you solve this one, you get the very similar formula, but it is 1 minus cosine x over 2 on the inside. And so I'm make a little box of our three formulas. Tangent has three variants. Tangent 1/2 x. You can have plus or minus 1 minus cosine x over 1 plus cosine x in square root. This is sine x over 1 plus cosine x. Or 1 minus cosine x over sine x. Those are your half angle identities. If I call this one A, B, and C. To go from A to B. You multiply. Inside. By 1 plus cosine x over 1 plus cosine x. And you'll see that this, when you use some formulas, breaks down and gets you to the sine x over 1 plus cosine x. And if you wanted to go from A to C. You instead multiply by 1 minus. Now, the way we got this formula is pretty useful. We're gonna use this a lot in Calc 2. Well, not a lot, it shows up in Calc 2. But the actual half angle itself. Like actually using an application is only so useful. Instead of like we found sine of 15 degrees by doing. Sine of 45 minus 30. We could find sine of 15 degrees by doing sine of 1/2 30. So let's look at a quick example before I tell you to get out. How about that? Find sine of 22.5 degrees. Well, 22.5 is 1/2 of 45. So if I say theta equals 45 degrees, this is sine of 1/2 theta. And we have the theta form sine of 1/2 up there. This equals plus or minus 1 minus cosine theta over 2. Which is plus or minus 1 minus cosine of 45 over 2. But it's not gonna be plus or minus, which sign should it be?
Positive,
Why?
because it's 45 degrees.
45 degrees or 22.5 degrees, they're both in quadrant 1. It
Yes,
will be the positive one, so let's scribble out the minus. And this is kind of ugly. This is like square root of 1 minus square root of 2 over 2 over 2. But we're able to find a value. Like I said, without a calculator, sure, we have an exact value without a calculator. But like, how useful is that? Could you use this to solve anything, use it in a problem in real life? That's not like a square root of fucking square root. This isn't helpful in its current form. You would want a calculator to do anything useful with it. So like these half angle formulas and double angle formulas, using them in an actual problem. Nowadays isn't like as useful. It is useful in calculus when we switch back and forth between stuff. And it's used for verifying trig identities and stuff like that. But that's how you could use it in the problem. Any questions? I don't think I'll have half angle on the test either. I don't think it's like, what are we gonna do, make you fill out a stupid problem like this? And memorize a formula you won't even remember in fucking 6 months. Important part is you see, do some problems on the homework, so like. You've got some experience with it and you know like if you need it again, where to go get it. But other than that, you are free to GTFO, have a good day. I will see you on Monday if I don't see you on Saturday.
all right, see you on Saturday, Professor Jones, have a good weekend. I mean, week, yeah.